Hello gamers, my name is Aiden Bai, and for my project this year, I created a JavaScript library for developing performance-focused web applications.
Back in the pioneer days of the web, websites started out as extremely simple and static. They were often non-interactive and didn't require any JavaScript. Nowadays, interactivity is required. Just think about it. When you go to Amazon or Google and click on a button, some action is performed. That's interactivity. To perform interactivity, JavaScript is required. However, JavaScript is often cumbersome to work with, so what developers have done is they created JavaScript libraries to help simplify this process. However, these JavaScript libraries are slowly becoming more and more complex and non-performant, resulting in a bad user and developer experience. Overall, this is a major issue for developers. To fix this, I made a library that was both fast and simple. For speed, I use conservative execution, which is just don't do things that they don't need to be done, immutable patterns, which is don't change things that they don't need to be changed, and a lightweight core, allowing the application programming interface or the API to also be lightweight. For simplicity, I use scalability through components, which is the ability to duplicate things and they would just work, as well as reactivity, which I'll demonstrate in figure 1. Imagine this is a spreadsheet. Cell C3 depends on cell A3's content, so when cell A3's content is changed, cell C3 content will automatically change. This is not the case with normal JavaScript. I wrote my codebase in TypeScript and built it with Rollup and Babel. I host my codebase on GitHub and publish it through NPM and Unpackage. For testing, I use Jest and ad hoc testing on the side, and I wrote all this in VS Code. For my procedure, I start off by creating the core and the API, which is the main part of the code base. Then I did unit testing and debugging over and over again to make sure the code is bug-free and safe to use. Then I publish it and promote it so other developers are aware of it and can integrate it in their own projects. Before I go into the implementation, I just want to make some quick preliminary notes. My implementation compared to its contemporaries such as Virtual DOM and KVO is much more memory light as well as fast. However, it's much more coupled with the DOM. The implementation consists of 2 phases, the compilation phase and the runtime phase, as well as 2 cycles, the initialization cycle and the reactive cycle. I won't be going into detail, but essentially what it does, it syncs some data. So for example, if we take a traffic light, the data of the traffic light for green, yellow, red, is the state of it, so what color it is. If it changes from yellow to green, the state changes and it will sync the website's content with that. So because of its really simple design as well as focus on performance, it's really fast. So I use the JS Framework Benchmark guidelines, which are really popular guidelines and are used as like a baseline for a lot of articles that describe the performance of libraries. As you can see in figure 5, I made a table of benchmarks. Essentially what benchmarks are, benchmarks essentially tests that gauge the performance of some certain task a library can do. Green means very good performance, red means not good performance, and yellow is the intermediary. As you can see, the baseline or no JavaScript libraries in the green as are expected, and Lucia is in the green, signifying very good performance. However, the mainstream libraries like React and Angular are in the yellows and reds, signifying subpar performance. This table consists of both qualitative and quantitative benchmarks just to get a full diagnosis of each library. And one note I would like to make is that Lucia's scores are very near the baseline, signifying really good performance. This is all summarized in a weighted score in figure 6. As you can see, it's visualized, and you can see Lucia is really, really fast. It's 5 times faster than the average of the other libraries. As a result of its exceptional performance, it's being used by German tech startups as well as people in Hack Club. It's been featured in major developer publications like Hacker News and Tech Media. In response, it received over 440 plus stars and has received over 20,000 plus unique visitors. In conclusion, it's super simple to integrate and it's extremely fast. It's already been implemented in many use cases that we saw before and it's production ready. Personally, I learned a lot about how JavaScript libraries work, and through this 8-month journey, I was able to actually create something that developers use, and I'm proud to have done that. For our next steps, I want to promote this to more developers and create tooling for a 1.0.0 version. Thank you so much for listening. Let me know if you have any questions or comments. Thank you for your time.